In this video, I'm going to teach you how to find the determinant of a matrix. Now let me remind you that the matrices that we are working with are 2 by 2 matrices that have 4 elements, A, B, C, D. So if I'm talking about finding the determinant of a matrix, let's call this one matrix M, I might write DETM, the determinant of matrix M, is found by the product of A times D, so you're going to multiply A times D, minus the product of B times C. Notice that you'll always subtract the two products. You're going to get a number, just one number, that represents what we call the determinant. What does the determinant do is it tells you or can give you two thoughts about what it's representing. So one thing you might be asked to do is to find an inverse of a determinant. The inverse of a matrix. If you're asked to find an inverse of a matrix, first you're going to find the determinant just to even see if there is an inverse. The other thing the determinant can tell you is whether or not the system that this matrix represents has a solution or not. So let me give you an example. I've got two examples up here. We're going to find the determinant of A first. So if I'm going to find the determinant of matrix A, what I'm going to do is take the elements of matrix A and I'm going to find their cross products. So A times D, negative 3 times 5, negative 15. Then I'm going to subtract the product of 2 times negative 4. That's a negative 8. Remember, when we have minus a negative, we think of it as add the opposite. And so technically you're looking at negative 15 plus 8, which is a negative 7. This number right here is what we call the determinant of matrix A. Now what that number tells you, because we did get a value, tells you two things. It tells you this matrix has an inverse, So if you need to find the inverse, this is a way to find it. It also tells you that the system that it represents has a solution. The system of linear equations has a solution. Could be one solution, could be infinitely many, but it has one. As opposed to what happens when the determinant doesn't equal a number. Let me show you what I mean by that. Let's find the determinant of matrix B. We're going to use this same rule to find the determinant of matrix B. I'm going to multiply 6 times 4, 24. I'm going to subtract the product of these two numbers, B times C. Negative 3 times negative 8 is a positive 24. You notice how 24 minus 24 equals 0. This is what I mean by, I know 0 is a number, but if you get a value for the determinant of a matrix other than 0, then you know it has an inverse and the system has a solution. Conversely, if you do get a 0 for the determinant, what that is telling you is there is no inverse. That matrix has no inverse. And it also tells you that the system it represents has no solution. So maybe now you understand why we call it the determinant, because it determines something about the matrix. Has no solution. So if you get a 0, there's no inverse. If it has a 0, the system has no solution.